here I prepared 6 examples. The first one is a Landolt-Börnstein bookshelf. It's a book series, Lexi book series I introduced. I will show you where you can find it in our database. Then the second is a very common example of the surface tension of toluene and benzene, how to compare them on the platform. Then the third example is what's the crystal structure of lithium, cobalt, oxide. Then the fourth example is how do we find and read the phase diagram, for the alumina, copper, and the lithium alloy system. The fifth is how do we find the band gap and Hall mobility of semiconductor. The last one is we have been talking about how to find the property for certain materials. Then how do we find a list of materials that meets certain property? So we also have such kind of functionality on our platform. Okay, then now we travel back from the slides to the website. Okay, so now what we are looking at is a website of SpringerMaterials. It's a database. The address is quite simple. Just remember it's materials.springer.com. If your institution or university subscribe to this database, there's nothing you need to do. You just click and open this website. You can already start the searching. But in some cases, if not, it's not the case. Maybe your lab is subscribed by user accounts. Then you have to log in from the right upper corner. Okay, so this is the homepage of this database. We also give you some cutting edge, the new news of the database, all the news in the physics, chemistry, or material science disciplines. But on the left side, you can find all the collections. If you scroll down, you see there's a function called there's a section called Landolt-Börnstein bookshelf. So that's where you can find all the information for all the volumes for this book series. As I mentioned, there are 540 volumes of them. So it's difficult for your lab, the lab in your university or research institution, to keep all of them. And right now, SpringerMaterials is the only place that you can find this book series. So for the Landolt-Börnstein book series, now you have 8 groups of books, and also we added more, such as SpringerMaterials Fundamentals. That's a different book series. It's also the same type. It's a reference book with datas. And also there's an additional resource. There's more book series, related book series. So let me open the first volume that was published for 1961. And this is the first volume of this group and the first volume of this edition. Okay, it's here. Then what we can see is that we offer you all the chapters. So I have to apologize that because right now I'm presenting with my own computer, so that's why I have to connect to VPN. It's a little bit slow, but if you are using it in Japan in your office, this shouldn't happen. So you can see in this first volume, it has 76 different chapters. So you open it. Now we will lead you to this book chapter. This book chapter, you can either decide to read it online or download the PDF version. You might get interested where does this data comes from? And so this book is a reference book. It's a kind of a boring book because it's all data table, curves, equations, formulas. So definitely not some books you will read for fun, but it's a very unnecessary reference book for your research and teaching. So you might want to ask, where does this data comes from? So what our editors did, I mean the editors for this book series, is they will invite the leading scientists in this field. These scientists, they will reveal all the publications, the articles published, not just by Springer Nature, by any publishers on this topic. They will review all the data published in this period of time, and they will evaluate and also check the experiment that's try to repeat this data, and make sure these data, they are reproducible by multiple groups in the following research. Then they will make the decision this is of trustworthy data and include it into this book series. Okay, so this is about the bookshelf. So I do encourage you, when you have time, to quickly flip it through, locate where which chapters or which book volumes are relevant to your own research, and take a quick look. And next time, if you need any data for your research, you know that Landolt-Börnstein books have the data you need. Okay, the next case is about how to search for the surface tension of toluene. What we can do is, usually we suggest you just type in toluene as the name of the materials, and you click search. Then our system will find everything related to toluene. So here, to save the time, we'll directly jump to this result. So here we're looking at the surface tension of toluene. We look at this curve. So all these curves are, all the graphs are interactive. You can read the points. You can read the measure the number behind each point, or you can either take a look at the system temperature, or look at these graphs, these points, by system temperature or by system pressure. So in this curve, you have over almost 500 different points. So you can decide, we also have this interactive functionality. You can decide, I want to zoom in. Maybe I just want to look at this small window. Then we can zoom in with this slides bar. Or, you can always go back to the original full curve. So other than the sliding bar, we also offer you the comparison functionality. So you can decide, I want to compare the surface tension of toluene with benzene. Then here we give you the functionality here. So you just type in the pure benzene. So now you can compare the surface tension of toluene and the pure benzene directly on this graph. So it's very handy. So we do offer you up to 3 substances. You can compare them at the same time on the screen. You might want to ask, why not more? I mean, technically speaking, we can compare as much as we want, but eventually this graph gets too complicated for you to review. So we limit it to 3 here. You can see the green one is benzene, the orange one is benzene, and the green one is a toluene. But there's more you can do. We do offer you the download of all the data in this curve. So for example, here we show the table. It shows the toluene, its surface tension, the condition, the original references, and we have this cross-ref built it in. If you are interested, you want to take a look at where the original literature, this data was published, you can just by click on the cross-ref, we will direct you to the article page. Also, I want to mention that I said we have almost 500 points for toluene, the surface tension of toluene. So if you are interested, you are more than welcome to take a look at these references. So the data was actually, these 500 data points were coming from about 100 articles. The oldest one was published in 1907. The newest one was published in 2014. So basically, our scientists were not just evaluating the data, they also consolidated the data from different literatures. So that's why we can quickly get this curve and download them. But if you want to do it by yourself, it sounds like a mission impossible, that you have to review probably thousands of articles, find the trustworthy data, and it's a 100-year range of articles, and you need to consolidate them together. So that's very tedious work. But in SpringerMaterials, you can quite quickly download them. So if you scroll down on the right side, we do have this function called actions. You can either download the data, download the plot image, or download the table, or we can download the citation. If you want to cite this data, then download the citation. We already build all the information in. So next is a lithium cobalt oxide crystal structure. So this is a very important lithium battery materials information property, and this data, all the we do cover a lot of data on the lithium battery. So the Nobel Prize winner, Professor Goodenough, he was the one who evaluated this data for our database. He started to work with us. He started to collaborate with us since 1970s. And we don't have time today, but you can try to search our database. It's a majority of them is data, but we do have some very original literature were drafted. It was drafted by this famous scientist. So Professor Goodenough, he drafted a lot of good review articles. It was also included in SpringerMaterials. Unfortunately, he passed away last year, but he did contribute a lot to this database. So here we come back to the lithium cobalt oxide, the crystal structure. We already have all the crystal structure zip file built it here. So most of the case, you just download the zip file. So we do provide you with all the parameters of coordinates of the crystal structure, but it's all here. But you really don't have to build them by yourself. Majority of the case, we download the zip file, put it in the software, for example, Diamond. You can study the crystal structure or do the XRD simulation. Very handy. Then also we have this functionality I really want to show you. Sometimes, if you are teaching or you're having a discussion with your team, then usually a three-dimensional crystal structure will really have benefit the communication. So we do have this 3D crystal structure, interactive structure built in our platform. So you can zoom in, zoom out. We can decide to take a look at the unit cell or multi-unit cell, and we can do different. We also offer the different with a visualization, and we do different measurements. For example, we can measure the distance of these two atoms, or we can measure the angles, for example, the angle among these three atoms. Then we do offer the export functionality. When you get the right image, you can export it, or you can in different format. So here, if you right click on the empty space, then you can have more functionality. So things the you know the Windows system I'm using right now is in Chinese. So but usually when you see them, they are in English. So for example, we can let them crystal structure spin. So there are a lot of visualization functionality built in. If you are teaching a class for your graduate student, this can be very useful. And we do know a lot of in a lot of universities, their teachers, they're teaching crystal structures or phase diagram. They're using this to help them their student to finish their course or assignment. Okay, then the next we come to the phase diagram. Like I mentioned, we do cover a lot of phase diagram in our platform. So what we offer you is you can take points easily. So in the past, this is difficult because we get the phase diagram from article in paper, in PDF file. How do you measure it? You print it out, use a ruler to measure it. I mean, it will give you the information, but it won't be precise enough. So on our platform, we do offer you the point record. Then you can download the graph or download the points you measured for the physical diagram. Then the next example is about the semiconductors. For example, for gallium nitride, we can measure its band gap. So here we do offer you the download, the CSV download. Then in this file, you can have all the data for the band gap of gallium nitride. It's already built it in, especially if you are doing calculation, computational material science. In this way, you can already have a large volume of data form with its original references number and references link. So it is very easy to use. So last example is how do we search for materials? Like I mentioned, all the examples, we know the materials or substance. We want to know the certain property. But in a lot of cases, especially when we design experiment or we are trying to solve problem, we are more like I need a materials or substance. It has certain property. How do I know in the world how many materials or substance they do meet such kind of requirement? So think about it, it's difficult, even more difficult than I want to find the property for certain materials, right? Because imagine probably there's no place to provide you with a single list, right? But in SpringerMaterials, we do have such kind of functionality right now. It's hide it unless you attend such kind of event, and we will teach you. We'll tell you how to do it, but you won't be able to tell from the website. That's why right now we are also trying to improve here. So come back to the case. We want to know all the materials or substance. It has a refractive index above 0.2. So we search. You enter this formula equation here. Then we will provide you with two lists. One is all the substance and mixtures with a refractive index above 0.2. Or we have semiconductors with meet such kind of requirement. So here we click on the link. It will drive us to the results. And so in this platform, we do cover over 8,000 materials or substance. Its refractive index is above 0.2. And for semiconductors, we have about 50 of them. So of course, right now, what we can do is we can search for properties. It doesn't have a units like a refractive index or dielectric constant. We are moving there. Hopefully we can provide such kind of functionality for all the materials and properties in our database. But it's like a work in progress. Okay, so come back to these are the demo part. we take a look at this platform, how it works. And I think it's very important you know that this database, the name is SpringerMaterials. Its website is materials.springer.com.